appreciation and depreciation. But first off, let's talk about percentages. So, if I say you have 500 fish, we don't increase or decrease, what percentage of fish do you have? You have 100%, correct? So let's talk about something else for a second. What is 84% as a decimal? 84% is a decimal. 0.84?
Yes, a decimal.
0.84. Yes, is 84% is decimal. So what is 100% as a decimal?
1.
1. How did you get that one? Then 84 was 85. All right. So we're agreeing that if we neither increase nor decrease, we're at 100%. Yes?
Yeah.
Which is 1.0 as a decimal. Okay. So let's all discuss this. If we are increasing by 20, just do their second one second. If we're increasing by 20%, what percent would we be at? Percent would we be at? Not decimal. 120%, correct? So if we're going up by 20%, everyone's paying attention or I'll lose you. If we're going up by 20%, we're at 120%, correct? As a decimal, that would be 1.2. We agree? All right. Now, what if we're going down by 20%? What percent would we be at? I have no idea what you all just answered, but it was just 80%. We would be at 80%. So, what is that as a decimal?
0.8.
0.8. That's all these formulas are doing. Okay? So let's look at this formula. Yep. We're there. This appreciation formula and depreciation. So do you see this one is 1 plus I being the interest rate? Why is it a 1? It's 100% as a decimal. This one is 1 minus the interest rate. Why is it 1? 100% is a decimal. Exactly. So this is what we need to know. I is the interest rate in decimal form. Okay? Now, what do you guess F and I stand for when we're talking about amounts? Initial amount is the capital I. That's what you start with. What do you suspect F might be? Final amount. What might N be? Number of somethings. Starts with a Y. Rhymes with years. Years. Number of years. So, the N doesn't change. The I and all the spots, they don't change. But it does matter if we appreciate or increase or depreciate or decrease, because then we have to subtract or add. So let's look at example 1. Example 1 says, the initial price of a car is $30,000. What letter is that? Capital I. The value of the car depreciates. So what the heck does that mean I'm going to do? Which means I'm going to do what? Minus. So I'm, oh goodness. So I'm going to have something, and then in brackets I'm going to have 1 minus something. Correct? That's what the depreciation means. It depreciates by 20% per year. What is that going for? For what? What letter? Little I. Lowercase I. So 0.20. And it might not say per year, listening. It might say per annum. That means per year. A-N-N-U-M. It means annum, means per year. Nothing different, okay? They often use annum. Okay, if the car is new in 2005, so a new in 2005, that means in 2005 it was worth 30,000, correct? How much will it be worth in 2010? What did they give me? The years. What is it? Yeah, N is 5. And what am I looking for? The final amount. What it's worth in 5 years. Correct? Okay, let's fill in what we know. F we don't know, so final equals 30,000. 1 minus 0.20 to the 5. I like simplifying or putting it into my calculator. 0.8025. Now guys, can you pay close attention here? Because I get this wrong on the test all the time. Looking. People will tell me this is decreasing by 80%. It's not decreasing by 80%. Where are we always starting at? Starting at 100. So what's it actually depreciating by? 20. So it's how far away it is from 1, correct? If it's below 1, it's decreasing by how much? If it's above 1, it's increasing by how much? But a lot of people will tell me 80%, which is not true. All right, typing it into your calculator. How much else? 30?
Yeah.
0.4?
Yeah.
Gauge. And then it says the car will be worth, yep, $9,830 in 2005. That's what I had the whole time. I don't know where you got it. Say a little prayer for me. Hinting. Throw a prayer out for me. Just toss one up to good old God up there for me. I think I might need it. All right. That one was easy because we didn't know F. What happens if we don't know N? Because N, guys, often we're not going to know N. And the reason why we're not going to know N is it means the variable is going to be in the exponent. And the variable in the exponent means we have to use exponents and logs, which is the unit you are in. So hence why you're often missing the N. So let's talk about it. It's not crazy hard. So here it says, how long will it take to the nearest tenth of a year? Weird. They want us to find N. It's as if we didn't see this coming. For the car to be worth, that's the point, half its original value. So now what do we know? The initial is what? Nope. What's the initial? 30,000. What's the final worth? 15,000, half of it. Did my interest rate change? It's N that I'm looking for, correct? So let's fill in what we know. So we get 15,000 equals 30,000. 1 minus 0.2 to the N. Okay. One thing I want you to know, we're going to get into conversions tomorrow, or not tomorrow, you grab Monday. But what I want you to know is, if you know the final and the initial, like if you know both of them, always divide your initial over. That should be your next step. So I'm going to, always. So I'm going to divide that 30,000 over. So I have 0.5 equals 0.8 to the N. Now currently the only way we know how to solve this is common base. We can't make those common base. The only way we can do it is our calculator, y1, y2. But there's actually an algebraic way. I need you guys all to pay attention. So we're going to teach this ahead of time. If I don't know the exponent, I need to get it to be like n equals something to get an answer, correct? If I don't know the exponent, what I do is I convert exponential to a logarithm. Okay? So how do we do that? this is how I do it myself personally. I say the base of the exponent becomes the base of the log. So when you do a logarithm, you write the word log, and then there's going to be a subscript down here. This is called the base of the log. Okay, down there. So, let's look here. What is the base of my exponent? I did not. That's a marker. What the heck? Stop it. Okay, I guess I'm writing it. Cool. Really want to write it twice. Okay, what's the base of my exponent? 0.8. So that's going to be the base of my log, 0.8. So it's like a subscript on the log. Can everyone do that? Base of the exponent becomes the base of the log. And then what I do is I say, what's friends doesn't stay friends. So currently, what's friends? 0.8 and n, correct? Can't be friends in the next one. And I do need something to be beside my log at the same height as the log. You see how this is a subscript? It's lower, but this and this are the same height. So what's going to go beside it? 0.5, because what's friends doesn't stay friends, right? So the 0.5 is going to go beside it, and it will always equal the exponent, which is n. Woo! We just isolated n. Now, if you have the new calculators, follow along. You're going to go math. Yours still probably works. Does yours have the exponent on it pop up? If your exponent pops up, that's a new calculator. Everyone just try this anyways, unless you have a TIE3, you ain't got no chance. If you have everything else, you might. So go math and arrow up, just so you can get the bottom list faster. And you want log base. Yeah. Press A. And then just type it in the way it is. Carson, you know how to type it in? All right. If you have the older calculators have to type it in like this. Watch. They have to go like this. And use the log button on the normal left-hand side. So if you don't have the log base button, when you go math and arrow up, you have to go log 0.5 divided by log 0.8, which will get you the same answer, so you can try that out as well. The log button is the one that's like over by the other one's log. So by like the 9 or 8, 7? Yeah. Yeah. 6, 5, 4. Counting smalls.
Go pick it up.
You have to close your bracket. You have to go like log 0.5 by the log. No. I have log 0.5 by the log. Yeah. Okay, does everyone have it? So if you have the log base button, my point is, if you have the log base button, use it. Way easier. Okay? All right, what did you get for n? 3.1 years.
Why would you do 3.1? Why would you decimal 100% plus stuff I'm saying.
Mm-hmm. All right. I want you guys to try example 2 and example 3. Go. Okay. The population of a city was 25,000 on January 1st, 2000, and 250. Okay, we're going to pray for me again. 310,000 on January 1st, 2008. Which one's initial? Which one's final? 250,000. I can see why you were going for the 25,000. It was something I said earlier. And the final is 310. And we know this because the years are later. Yes. And yeah. So, we are going from a smaller number to a bigger number. So we are whatting? We are appreciating. We are increasing. Yes, we are. And I get people using the subtraction formulas. It's so sad. Okay. if the growth rate of the city, and then they call me over, they're like, Mrs. Lepp, it doesn't work, it's giving me something negative. And I'm just like, yeah, it sure is. If the growth rate of the city can be modeled by an exponential function, the average annual growth rate of the population, they want this. What's the years? 8. Let's go. So we get 310,000 equals 250,000. Bracket 1 plus I to the 8. We divide by our 250,000. And then I keep the fraction because I don't want to use a decimal that could possibly repeat. So I got 31 over 25 equals 1 plus I to the 8. And then people are like, Mrs. Lepp, I'm going to have to convert to a log. No. The only way you can convert to a log is if the variable, if you don't know the years. Right? If you don't know the years, convert to a log. If you do know the years, you do math that you've been taught before. That's it. Okay? So we're going to have to take the 8th root of 31 divided by 25. And then I get 1 plus the interest rate equals the 8th root of 31 over 25. And then how do I get I by itself? Subtract 1. So I get I equals 8 root 31 over 25 minus 1. And what is my interest rate? In decimals. Your decimal. You can go 8 math number 5 if you want the 8th root if you don't know how to find it on your calculator. 8 math number 5. Number 5 has the little x in the root symbol. Did you get a decimal? Anyone? Bueller? Bueller? Yes? Did you get it? Oh, you just raise your hand. Let's go. Let's well figure it out. No.
0.27.
0.27. 3. What?
I have to actually get it. 2723.
There we go. You have to have it. This is 27%, which is a little shady. Okay. 0.0273. Like that? Okay. It wants it in a percent, so you have to times by 100, and it wants it to the nearest tenth of a percent, so it's going to be 2.7%. Okay. And you write a sentence, whatever I remember. Okay, in 2002, the population of the city was 160,000. It's increasing at 4.5%, you should say, per annum. That cut off. Write an equation that represents P, the population of the city, as a function of the number of years N since 2002. So we don't know the population. We know that there's initially 160,000. And then are we increasing or decreasing? Increasing or decreasing? Increasing. So it's 1 plus 0.045 to the n. So my equation is going to be 160,000 bracket 1.045 to the n. And we want in the year 2005. How many years is that? 3. Everyone give me 3 on their hands. Go. That's 4. That's scary. Only one. I did it weird. I've never seen someone do it this way.
Really?
Yes. This was weird to me too. Guys, this is 3. This is 3. I don't care what you say. This is 3. This is weird. This is weird.
Yeah, how do you do that?
Okay, yeah. This is 3. I don't care what you say, 3ers. And this 3er. That was unique. It's actually, I actually like it better than this one. I do.
This one is just hard.
This is 3. You think this is the most common? I just saw a whole bunch of people hold up 3 and I was like, wait a second, these are all weird. Mine is correct. Okay, going back to this. Okay, P equals 160,000. 1.045. Your option didn't even hit my brain. Like all I thought was this one and this one. That would work. To the 3. So what do we get? Are we going to get a number bigger than 160,000 or smaller than 160,000? We better get bigger. It says it's increasing. So what do we get? Typing it in. 182. So 587.
What around population?
We would round down, actually. 586. Can't get a partial person. All right. Let's go to the next page. Yeah. The population in 2005 was 182,586. You're welcome. No. Okay, let's talk about this one. If the population continues to grow at a rate, determine the number of years. Weird, they're asking us for a number of years. Shocking, they're going to make us convert to a logarithm because we're in exponents and log. Shock, I know. And then they want the number of years to the nearest year, so that's no decimal places, for the population to double. So we go 320,000 equals 160,000, bracket 1.045 to the x, and we know our initial and our final, will always divide them out. And so we're going to get 2 equals 1.045 to the x. How do we get that x to come down? It's an exponential equation. How do we get the x to come down? Convert to a log every single time. So how do we convert? The first thing we do is we write the word log. And then the base of our exponent becomes the base of our log. What's the base of our exponent?
2.
Not true. 1.045. Base of the exponent. Yeah. You were very confident. Yeah, I like that. Not the right number, but confidence was 110%. Okay. And then what has to go beside it? What's friends doesn't say friends.
2.
And it equals x. Type it in.
50.747.
Pardon, what?
It's 15 points.
Years with 60 years.
So your sentence would be, the population continues to grow at this rate. It will take 16 years for the population to double from the year 2002. Write the whole thing out with all the words and all the numbers. Not time to be short on your pencil. I'm not saving pencil right now. Okay, example 4, go. So this one says, number of the lake fish in the lake is decreasing by 5% per year as a result of fishing. Write an equation to represent the number of fish after t years using NO to represent the initial and NT final. So we're going to get N of t equals N sub O, 1 minus 0.05 to the t. So N of t equals N sub O, 0.95 to the t. So we know it's decreasing because it's between 0 and 1, right? That base between 0 and 1 makes it decrease. How much is it decreasing by? 5% because it's 1 below, or 5% below 1, right? We always start at 1, not 100%. Okay, if there were 2,500 fish present in 2000, how many would be present in 2005? So we want to know the final. 0.95, how many years? 5. And we get 1,934 fish. Make sure you write a sentence that says you would expect there to be 1,934 fish in January 2005. Okay, how many years, little typo, to the nearest 10th would it take for the fish population to reduce to half? So we need 1,250 as our final, 2,500, 0.95 to the end. We have our initial and final, we always divide them out. I can only put a decimal if it terminates, which means stops, correct? And that stops. If it's like a repeating decimal, I have to leave as a fraction, because then you're rounding before the final answer and you will get it wrong. All right. Once again, I don't know the year. If I don't know the year, I have to do what? Log. So I get log base what? 0.95 0.5 equals 13.5 years. So it takes 13.5 years for the fish population to reduce to half the number in January 2000.